And welcome back. And for the third video, we are going to go over some of the analysis you can do in SPSS. Specifically, we're going to cover descriptive statistics, comparing means, and linear regression. So go ahead and open back up your data set that we have here. And for the first time, we are going to take a look at the output document. Now, the output is just going to show you all the things that you've done as well as the actual output of your analysis. So let's go ahead and start with some descriptive statistics. Go into Analyze, Descriptive Statistics, and we'll start with descriptives. Now what this is going to do is just show you some basic statistics that go on with your variables. So I have selected age, visits, and utilization. This is going to show me just some basic numbers to go along with this. Go ahead and hit OK. And you can see in this section we have the descriptive statistics. So the N is the population. So we have 224 people who answered age, 198 for visits, and 231 for utilization. And you can just see the minimum, the maximum, the average. So the average age is 68. The average visits in the past 30 days were 9.9. And the average person does 1 1/3 classes. And that's about it for descriptive statistics. Let's go on to something that gives you a little bit more insight, some crosstabs. So go ahead, go to Analyze, Descriptives, and Crosstabs. And for this one, I have selected gender and utilization to compare. So if you go ahead and select those, hit OK. Now I have all my crosstabs. So this is showing me is how many people are in each group depending on their gender and their utilization. So we can also see that this 99 that is included, that is a variable that we computed earlier. If you do not need that or do not want that, you just have to go into select cases and to exclude that 99. So basically we can see that the group in the one gender participate in classes more often than the zero gender. But if we go to the chi-square test, which you can select in the options for doing a crosstab, you can see there's really no significance in any of these data points. Maybe you'll have more luck when you run your analysis. Next, we'll go on to comparing means. Now, the first item we do in comparing means is the actual means function. Comparing means, and what this is going to do is compare the differences in your means dependent on the group. So I have selected visits against gender. So this is going to show me what's differences in visits depending on if you are in each gender group. Go ahead and OK. And down here, it shows me exactly what I was looking for. People in the zero gender group visit about 9 times. People in the one gender group about 10. Those people who did not include their gender visit very often. And again, if you do not want to include those in your analysis, you just have to go into split cases or select cases and exclude them. Now for a one sample t-test, we go to compare means, one sample t-test. And now a one sample t-test is good if you have an item that you have the average for the population, and you're comparing your sample against the population. In this case, we do not have the average for a population, so we're just going to have to make something up. For this, our recommendation variable, we're going to hit something right in the middle, so I believe this is a 1 to 10 variable. Let me double check. Recommend. Yep, looks like it's a 1 to 10. So I'm going to just put this as a 5, somewhere right in the middle, and we're going to see if our recommendation scores are different from the mean, which is 5. Go ahead and OK. And we can see the mean of our one sample t-test is 9.3. And is that significantly different from 5? So we go here and we see, yes, it is indeed statistically significant difference from the value of 5. Again, this isn't a great example because I do not have the population mean, but if you do in your examples, this is a great test to run. Next, we have paired sample t-test. Again, analyze, paired sample t-test. Now, this is great when you are comparing differences between groups on a single variable. So, for instance, I'm looking at, do people who participate in weight classes have changes in their likelihood to recommend? Do people in fitness classes have changes in likelihood to recommend? And any other variable you want. This is appropriate if you're looking for something that you did, like a manipulation, has any effect on your outcome measure. So I'm using these variables. I'm going to go ahead and OK. And this brings up my paired sample t-test output. Shows me the means for each section. Recommend is the same across all groups, which is exactly what we're looking for. And we can see there's no correlation between these, even though we see some differences in the correlation. And if we go down to the actual pair differences output, we can see that not a lot is going on. And even though we have now, if we go down to our paired samples output, we can see that even though there wasn't any correlations, we do see differences between the groups and significant two-tail differences. Finally, for the compare means, we're going to look at ANOVAs. And ANOVAs are great if you're comparing the differences between groups depending on your one factor. So for this factor, I have gender, and the dependent lists I'm going to be using are the ratings of how important these factors are in a gym, as well as your recommendation of the gym. Now we can see that the ANOVA has output here, and we can see all the differences between the groups and within the groups, but what you're really looking for is this F and the significance number. Now the only thing that came close to significantly different, was the medical field with a 0.059. That is still not significantly different because we would likely use a 0.05 alpha for our significance variable. And maybe when you do yours, you'll be able to see some significant differences, but in this case, we have not. Now, finally, we are going to look at regression, specifically linear regression. So go ahead and go to regression, click on linear, and I'm going to be looking at the differences or if there's any correlation between the age of the person and their level of income. So I put age in my dependent variable, and what I'm measuring is their income. So as age increases, will I see an increase in income? If I click OK, now looking at regression, we can see that these are our outputs. And we can already see that this is a pretty good correlation of 0.179. And our ANOVA and coefficients will confirm that the regression is significant. There's a significant relationship between income and age. And we can see it's a positive correlation, so as you get older, you have a higher income. Alright, that is it for this video. And that is it for the series of SPSS videos. Hope you have a great day. Cheers.